Good morning. Today we are going to deal the problems based on transportation, which is coming under the second unit of operation research. Okay, what is transportation? We are going to transfer the goods from one place to the other. It's called transportation. We all know that. So why it is there in your syllabus? Simply because of the reason that if you wanted to run a business, if you wanted to transfer the goods that you are producing in your company, as a mechanical engineering, you are transferring the goods from one place to the other in your company that manufactures so many products, then obviously you need transportation. So that is why this unit is there for you to discuss various problems which are occurred while transporting the goods. Right. What is the definition of transportation problem? So transportation deals with the transportation of a commodity from M sources to N destination. What are the sources? Sources is nothing but it is the warehouses, or it is the factory in which the products are produced. Destination, what are the destinations? Destinations is something where you just transfer the goods. Objective is to determine the amount of quantities to be shifted from M sources to N destinations. The main objective is to reduce the total transportation cost. Okay, what are the assumptions while solving the transportation problem? There are three assumptions. One is the level of supply at each sources will be equal to the level of demand at each destination. That is, in other words, we can say that total demand is equal to total supply. Then the second assumption is the unit transportation cost of a commodity from each source to each destination is equal to 1 or given. The cost of transportation is linear, or coefficient of all cost in constraints are unity. Now the general form of the transportation or mathematical form of the transportation is given over here. It is the special type of a linear programming problem. So that is why it is there something called objective function and constraint, then non-negativity condition is also there, which is the integral part of a linear programming problem. Then number 4, necessary and sufficient condition for the existence of a solution of a transportation problem. Suppose if you are going to solve a transportation problem, then you will be able to get some solution. If you wanted to get a solution from a transportation problem, then you need a basic fundamental condition. That condition is called necessary and sufficient condition of a transportation problem, that is equal to total demand equal to total supply. Then unbalanced transportation problem. What is unbalanced transportation problem? Suppose if you do not have total demand will be equal to total supply, then it is called unbalanced transportation problem. Then what is feasible solution? A set of non-negative values which satisfies the constraints is called feasible solution. Then what is degenerate solution? If a feasible solution contains less than m plus n minus 1 allotments. What is allotment? I will tell you when I am going to solve the problem. Okay, it's called degenerate solution. Then optimum solution. What is optimum solution? A feasible solution is said to be optimum when it minimizes the total transportation cost. The very important point is over here is minimize the total transportation cost is called optimum solution. What are the basic cells? The allotment cells are called basic cells. Non-allotted cells are called non-basic cells. Then there are a few methods available in transportation problem to find the transportation cost of the given problem. So out of 5 methods, according to our syllabus, we will have only 3 methods. They are northwest corner rule, least cost method, or matrix minima method, Vogel's approximation method. First 3 methods. There are about 5 methods to find the initial basic feasible solution of any transportation problem. Out of these 5 methods, we have only 3 methods, first 3 methods in our syllabus. So we are going to deal the problem based on these 3 methods today. Right. One is northwest corner rule. Second is least cost method, otherwise known as matrix minima method. Third one is Vogel's approximation method, shortly known as VAM, and row minima method, column minima method, which is not there in the syllabus. Modified distribution method, MODI method, is used to find the optimum solution of a transportation problem. Then maximization of a TP. We can also maximize the problem. Usually transportation problem will always give you the minimized result, but also you can also maximize the problem. Suppose they are giving the different values in the problem, like sales or profit from one place to the other, then you will have to maximize those things. Therefore maximization can also be done in the transportation problem, but we'll have to do one simple thing for maximizing the problem. So which is multiply all the entries by -1, that is maximize z equal to minus of minimize of minus z is the formula for maximization of a transportation problem. Now I am going to solve a simple problem in all the three methods. Find the transportation cost for the following TP. This is the problem. I am not going to write the problem again. It is there already there in your notes. Right. I am going to first I have to take the northwest corner route. Before that, for all the problems, we will have to check the basic fundamental condition of existence of a solution, which is called total demand equal to total supply. So we will have to check for this problem total demand equal to total supply. Otherwise it will become a unbalanced transportation problem. That is why we are going to check. So here, what is the demand for each destination? There are 4 destinations and 3 origins. O1 means origin 1, origin 2, origin 3. D1 means destination 1, destination 2, destination 3 and destination 4. There are 3 warehouses or 3 godowns or 3 origins from where you are going to dispatch the goods to 4 different destinations, for which it requires 6 rupees, which means this 6 means you are going to transfer the goods from origin 1 to destination 1 of a single commodity will take, that is unit price is equal to 6 rupees. Suppose if you are transferring 10 10 units of a particular product, then 10 into 60 rupees you are going to spend by transferring the goods from origin 1 to destination 1. Suppose if you are not able to understand what is origin 1 and origin 2 or destination 1 and destination 2, then I will give you a small example. Suppose you are now here in Erode, your factory is in Erode, then you are going to dispatch the goods to Salem and Coimbatore. Then Salem comes D1 and Coimbatore comes D2. Erode is origin 1. So if you are going to dispatch the goods, 1 unit of goods to Salem, it costs 6 rupees. That is what they are giving. The other thing is, supply is also given. How many quantities are available at your factory, that is at the Erode, which means 14 units are available, which means you cannot transfer the goods greater than 14, which means suppose it is required for 15 units or 20 units, it is not possible from the first origin, that is Erode. So in the similar way, we will also have the demand of each destination. Salem required only 6 units of particular product. Coimbatore requires only 10 units of the particular product. Before solving the problem, we have to check whether total supply will be equal to total demand. That is what we are going to do right now. So 6 plus 10 plus 15 plus 4 is equal to 14 plus 16 plus 5. So put together you will get a 35 equal to 35. So 35 is equal to 35. Therefore, total demand is equal to total supply. Therefore, the given transportation problem is balanced. Therefore, TP is balanced. If it is balanced only, then you will be able to solve the problem by using these three methods. Right. Now the first method is called northwest corner rule. Don't worry about origin and destination, we need only the data. So 3 rows and 4 columns, 6, 4, 1, 5, 8, 9, 2, 7, 4, 3, 6, 2. Now the availability at origin 1 is 14 units, at origin 2 is 16 units, and origin 3 is 5 units. Demand at first destination is 6 units, second is 10 units, and 15 and 4 respectively. Now the problem is going to solve by using northwest corner rule. What is north? We all know. This is north. What is west? This is west. What is corner? This corner. Suppose if you extend this like a table, then northwest corner. Northwest corner. This is the place. This is the cell at which you are going to put the first allotment. This is the place at which you are going to put the first allotment. So here this is the northwest corner. So where you are going to put the first allotment. What is allotment? How much quantity you are going to dispatch from one place to the other. That is called allotment. I already told you what is allotment. I will tell you later. So allotment means how much of quantity you are going to dispatch from one place to the other, from one source to the other destination. So here we are going to put the allotment. So destination demand is 6 units, availability is 14 units. So what are we going to substitute over here? We'll have to substitute. We cannot substitute 14 because, or more than 6, because it is the availability of the godown, availability of the factory. But at the same time, destination is only 6. So you can substitute either 6 or less than 6. But here you can substitute 6. Why less than 6? I will tell you this time. So you can substitute 6. Entire demand of particular destination is fulfilled. Therefore, cancel that 6. Suppose this 14 will become 14 minus 6 equal to 8, because you are dispatching 6 units of a particular goods from O1 to D1. Therefore, you will have only 8. Now there is no first column, because you are satisfying the demands of first destination. Therefore, it is fulfilled. You take out, you keep away from the further calculations. Now this is the northwest corner. Once again, the rule is in the remaining table, what is the northwest corner? This is the northwest corner. So you will have to put the allotment over here now. So what is the requirement? Requirement is 10. Availability is only 8. So you cannot put a 10 over here, like you put 6 over here in the first column, but you cannot put 10. All the demand cannot be satisfied in a single single allotment. Therefore, you can only put 8. Why? Because the availability is only 8. Therefore, put the allotment is 8, balance is 2. Now, the entire origin 1 stocks have been vanished, have been completed, finished. Now, we'll go to the origin 2. Origin 2, there is no point of, what is the northwest corner again? So, there is no first column, there is no first row. Now, only there are only 6 cells. So, this is the northwest corner. Therefore, you will have to put the allotment over here. The requirement is 2. Availability is 16. So, put 2 over here. Balance is 14. So, now the northwest corner is, now the second column will also be cancelled. So, now the northwest corner is out of these 4 cells. This is the northwest corner. So, put 14 over here, availability, but requirement is 15. Therefore, still 1 is required for the destination number 3. So, now second row will also be cancelled. Then what is the northwest corner now? These 2 cells only balanced right now. So, in which northwest corner is this. So, put the allotment over here, 1, balance is 4. 4 get cancelled, so put 4 over here. This is the basic fundamental procedure to solve a transportation problem by using northwest corner. Problem still not yet completed, but one more small calculation. Total TC, total transportation cost. Total transportation cost. How do you calculate the total transportation cost? If you are going to dispatch 1 unit of a goods from O1 to D1, it will cost 6 rupees. But here you are going to dispatch 6 units. Therefore, 6 into 6, 36 rupees. 6 into 6. Similarly, 8 units of goods at the rate of 4 rupees. So, 8 into 4 plus 2 units of goods at the rate of 9 rupees plus 14 into 2 plus 1 into 6 plus 4 into 2. So, put together 36 rupees, 32 rupees, 18 rupees, 28 and 6 and 8. So, if you add all those things, then you will end up with rupees 36. 128. So, transportation cost for transferring the goods according to the given specification, given requirement, given constraints is equal to 128 rupees by using northwest corner rule. Now the second method, the same problem will be solved by using least cost method, otherwise known as matrix minima method. Why it is called matrix minima method? So this is a form of matrix, 3 rows and 4 columns. So out of which we will have to find the minimum value, so that we will have to make the first allotment over there. Here also the same meaning. Least cost method, these are all called cost, transportation cost. So out of these 12 cost available, we will have to take the least cost first, not like northwest corner rule. So here least cost will have to be allotted first. Out of these 12 values, these 12 cost, what is the least cost? Least cost is 1. So we will have to make the allotment over here first. 14 is required. 14 is available. 15 is required. So 14 can be substituted. The remaining is 1. Still destination 3 still have 1 unit pending to be serviced or dispatched. Now the second least value, So otherwise the next least value. So next least value is 2. Suppose if we have more than one least value of same element, same value, then you can have option. You can put a particular guy can put this value as the first one, the second guy can put this value as the first one. Even though they are having different allocation for different times, the answer will not be changed. Therefore, I am taking this first. So 1, required is 1, availability is 16, so remaining is 15. Next, this 2 is the least. So required is 4, availability is 5, so 5 minus 4 is remaining is 1. So next least value is 3. So availability is 1, required is 10, so substitute 1 over here, balance is 9. Then what is the least value? Next least value 4. 4 occurred in 2 different places. Here also 4, here also 4. Choice is yours. You can substitute, you can allot any value, but unfortunately you cannot allot this cell because already this entire goods are being dispatched. All the 14 units have been dispatched. Therefore, there is no stock at the first origin. Therefore, you cannot substitute allotment over this cell. So the only availability is 4, which is also not possible because all the 5 units have been dispatched to different cells, different destinations. Therefore, this is also not possible. This is also not possible. So next allotment is, next least value is 5. So 5 is occurred in this one place, but here also not possible. Next is 6 not possible. Next is 7 is also not possible. 8 is possible. So 8 requirement is 6, availability is 15. So 15 minus 6 is 9, balance is 9. So 9, substitute 9, the only element left. So at the end of the day, if it is a balanced transportation problem, all the demand and all the supply will be cancelled. If it is an unbalanced problem, that will be discussed in the next class. So any one of the value will either in the row wise or column wise, there will be some value pending, some value will be remaining. Therefore, it is called unbalanced. There is some formula there or step is there to convert into balanced transportation problem. That will be taken in the next class. Okay, now we are going to find the total transportation cost. We have total demand is equal to total supply. So all the demands and all the supplies are fulfilled. Now we are going to find the total transportation cost. So 14 into 1 plus 6 into 8 plus, why we are adding these values? Because we are going to find the total transportation cost. Since it is a total transportation cost, we have to add 9 into 9 plus 1 into 2 plus 1 into 3 plus 4 into 2. So 14 into 1, 14, 6 into 8, 48, 9 into 9, 81, 2 plus 3 plus 8. If we add all those things, we'll get 156 is the total transportation cost for the given problem by using least cost method. So we have discussed 2 methods today. One is northwest corner rule, the other one is least cost method. Both will have different values, different transportation cost, out of which cost is minimum, you can take it for the calculation, take it for the transportation of goods. With this, we conclude today's session. Thank you, guys.